The goal of this project was to create a device to put on a rocket that would measure different flight parameters. These flight parameters include temperature, orientation, velocity, and elevation. The challenge was to create a device that could achieve all of these, was smaller than an egg, and could wirelessly transmit the data, while still being as light as possible.
We started this project by defining the problem that we were given. We stated what the customer wanted the rocket to achieve, and we split it into 3 sections: detect acceleration mechanically, record flight parameters, and transmit the recordings wirelessly. Next, we created a chart for how we wanted the device to achieve these tasks.
With the given problem definition, we moved on to the initial design phase. Here we made a rough draft of what we wanted the device to look like and how the different parts would fit together. Subsystems were designed individually to fulfill requirements set forth in the problem definition. A final schematic was made to show how the subsystems would fit together in the finished device.
The prototype was modeled using PTC Creo and manufactured in-house. A printable shell was modeled first, and each component was positioned inside to be sure they fit within the tight space constraints. The prototype mechanical accelerometer worked as intended, with little modification needed.
Each of the subsystems were tested to ensure that they would serve their intended purpose in the final version of the device. These were tested both for functionality and accuracy as thoroughly as possible without placing them in the final prototype. Each of these subsystems were tested and their outcomes were analyzed to check the performance of the final design versus what was expected of the device.